This is Pave It Black.
Hi, and welcome to Pave It Black, the official podcast of the National Asphalt Pavement Association. My name is Richard Willis.
And I'm Brett Williams.
And we're here today to talk accelerated loading facilities. And while a lot of people think our asphalt pavements are just oil and rock, the reality is there's a lot of research and a lot of engineering that's required to ensure that they perform as highly as possible. Now, the challenge that we have with most asphalt research is that if we were to put down a test strip, it takes years and years and years to ensure that that mix is going to perform in the field. But accelerated loading facilities allow us to hit fast forward a little bit and understand what long-term performance might look like for the mixes we place today.
So today I'm interested to learn a little more about the process for setting priorities and project scopes for some of the research experiments that are conducted at the test track.
So to help us learn a little bit more about the test track, we've invited the director of the National Center for Asphalt Technology, Dr. Randy West, to the podcast with us today. Welcome to the podcast, Randy. Can you tell us a little bit about yourself and NCAT?
Yeah, sure, Richard. Hey, Brett. So I've been the director at NCAT since 2007. NCAT is the National Center for Asphalt Technology at Auburn University. We are a research center that was established as a cooperative effort between NAPA and Auburn University back in 1986. And our mission is to provide innovative, relevant, and implementable research, technology development, and education that advances safe, durable, and sustainable asphalt pavements. So we have a great research staff here. We have some really unique assets. You're talking about the test track. That's our crown jewel of research in terms of our capabilities. But we love what we do. We love the opportunity to work in the asphalt industry and help improve asphalt pavements.
So you kind of touched on what the test track does or what your goals are with the test track. Can you maybe talk about some of the history around the test track and some of the things that you've worked on or that the test track's really taken on?
Yeah, there's a lot of history with the test track. It was originally built in the year 2000. That was a big year for NCAT. It was before I started working here, but I had connections to NCAT from earlier in my career. But it was built really at the time when the industry was trying to prove the performance of SuperPave and SMA. That was kind of the high interest areas of research at the time. There was another facility that people in the industry probably are knowledgeable about called West Track that was built out in Nevada. And some of the plans for the NCAT test track actually came from a proposal that NCAT did to get that West Track here. Of course, we weren't successful in that proposal that was built, as I said, in Nevada. But using those plans for that initial test track idea that was funded by the Federal Highway Administration, we took those plans and really put together a financial plan, a research plan, using state highway agencies really to fund research rather than the Federal Highway Administration.
So one of the things about the test track is you have an ongoing kind of 3-year reconstruction, rehabilitation process and bringing in new experiments and new things to discover. Sometimes you set up new experiments from scratch, from the ground up. Other times you have experiments that carry over from test track to test track. And so what's the process of trying to fill the test track with the most valuable experiments that are going to help agencies and industries continue to improve those points in your mission statement, the longevity, better life cycle cost analysis, better sustainability?
Yeah, well, we always start out by listening to the clients, which the test track historically has been mostly funded by state highway departments, but also Federal Highway Administration has been a sponsor, and industry. Some industry-sponsored sections have also come into play. The genesis for the experiments starts by listening to what the sponsors or the clients want to do. What do they want to evaluate? Is it a new pavement structural design, to prove out perpetual pavement concept? Is it to evaluate a new additive or a new mix design philosophy. That's how it usually starts, is just talking with those sponsors, listening to what they have in mind. Sometimes we hear similar ideas by different states, and we'll put together an experiment that we may call a group experiment. And we've done a few of those that have been very successful, where we're trying to prove something, and we put together 5, 6, 7 test sections that will help us evaluate that bigger experiment, that group experiment.
So with the test track operating on a 3-year cycle, it seems like you're somewhat locked in. So what are some of the ways the test track can react to fast changing focuses or a new innovation that almost shows up out of nowhere? What are some of the things that the test track can do to really help the industry or help agencies deal with some of those quick, here they are type of situations?
There often is new ideas that are kind of brought to the table for research. The research at the test track, it is expensive, and so it has to be generally an idea that's going to have legs for it to make sense to build a test section or a group of test sections. But we've always kind of evaluated some of the current topics of interest. If you go back 13, 14 years ago, warm mix asphalt was new, and we needed some information about how would warm mix asphalt hold up under the heavy truck traffic. So we had the opportunity, actually in the middle of a cycle, in that case, an existing test section had failed. Sometimes that's what we intend, is to actually test a pavement to failure. But by having that failure, we needed to replace the section with something just to kind of get it through the rest of the cycle. And somebody put together the idea of, well, let's try warm mix technology, and we evaluated that. The experiment for that left remainder of that cycle got put together really fast, and we put down warm mix and trafficked it for, I think, is about 1 million easels at the very end of that 2007 cycle. And that test section with warm mix was actually with Midwest Vaco at the time, before they became Ingevity, one of their warm mix technologies. And that test section stayed in place throughout the next cycle. So it was funded not just as a way to get that section through the rest of that existing cycle, but as a way to kind of prove the technology worked under the extreme loading that we have on the track. We've done test sections also with other kind of new technologies. Right now, we have an experiment with plastics, with recycled plastics as an additive in asphalt mixtures. As Richard said kind of in the opening, we're often looking for ways to prove whether or not something works. And so the timing worked out well for us to put together an experiment with some recycled plastics here at NCAT. And then we worked with our colleagues and partners in Minnesota to build very similar sections at the Minroad facility up in Minneapolis, or north of Minneapolis.
When you're in the research world, you realize that there's no such thing as a perfect research experiment. There's always something that's confounding or limiting. One of the things people talk about with accelerated loading facilities is that while it's great that you can get out there and put additional traffic on the pavements effectively, one thing that you don't see is the long-term aging that may take place in a real pavement test section out on the interstate that's there for 20 years. And so how do you consider some things like this, or how important or not is it when you look at kind of your conclusions and findings?
Well, the test track does allow us to look at aging in many regards, much more so than other types of accelerated loading facilities, like the machines that just go back and forth on a very small test section, things like the ALF or heavy vehicle simulators. Those types of facilities really are not able to account for any aging, or if they do, they have to do an experiment year one and then hold off on traffic and then put more loading on a test section year 2 or 3 or 4 to understand the effect of that aging. Here at the test track, because we are kind of in a real world construction and exposure to the elements, there is natural aging that is occurring to those test sections. Our cycles of research are typically 3 years, So we'll evaluate a test section over a 3-year period. But many of our experiments get continued on for multiple cycles. We still have on the track 2 sections that were part of the original construction in the year 2000. So they've been in place for 23 years now, almost 23. But then some of those test sections we do replace every cycle, depending upon what the sponsor group would like us to do. We'll need a test section to do a new experiment. But when we can and when it's the right thing to do, many of the sponsors for experiments do see the value in extending trafficking into multiple cycles. And that's been pretty common, I think, in some of the bigger experiments that we've done.
So you kind of touched on the fact that the test track's a little different than some of the other accelerated loading facilities, and just that scale and how it's constructed and out in the real world conditions. I think it kind of leads to some rather large expenses to really operate the test track and be able to do these experiments on the scale and to the level of detail that's done. And so I'm just kind of curious if you could maybe share some of the stories about implementation successes, because I'm sure that you've faced where some people are like, wow, that's a lot of money, and then start thinking about what you're going to get, what's the return on investment for putting this research into action and spending that money to really get the most for the agency or whatever customers or clients are really coming to NCAT to get the answers that they're looking for.
Brett, you unpackaged a lot there. I'll start out by kind of talking about the test track itself. It is 1.7 mile oval, and we have 46 test sections. Sometimes we'll subdivide a test section, so we actually may have more than 46. In every cycle, we don't replace all 46 sections. Our trend is typically to replace about a half of the sections, and then another quarter of the sections are sections that remain in place and continue traffic from our previous cycle. And it is an expensive operation. Number one, it's expensive to build. You've got 30 different experiments or test sections being built on the track. That's 30 production runs of different mixes with aggregates coming from a dozen different states, binders coming from different places, different sources, different binder grades, different additives being used. So just the process of planning and putting together a pretty complex build of 30-something test sections is a significant endeavor. Because we're part of Auburn University, which is a state of Alabama university, we're required to follow the same bidding, low bid kind of procurement for our research test section construction as a typical highway agency. So the test sections themselves, just to build them, is like a big puzzle, trying to put all the pieces together, and then working with a contractor that wins that bid to arrange the sequence of getting the mix designs tested. We run trial mix through the plant, and we do the testing to make sure that each trial mix meets the targets that we've set for in the lab. Once we're satisfied with that, and once the client or the sponsor is satisfied with that information from that trial run, then we'll have them produce the mix and pave it on the track. And typically that's multiple layers. So it's a complicated process just to build one test section, much less 30 test sections. And because it's complicated and you're basically taking control of the contractor's plant and their paving crew for 3 to 4 weeks, essentially, it's not an inexpensive endeavor to build these kind of test sections. But we've been very fortunate to have a really good local contractor work with us through the years. There's been the successful bidder, East Alabama Paving. They've done a remarkable job in working with us and helping us build the quality of the sections to get the experimental outcome that we want, and that is to have a specific mix design, a specific pavement structure built and we can evaluate the factors that we want to evaluate. The other part of the track that makes it expensive is the trucking operations. So we are applying accelerated loading using 5 trucks, 5 tractors that pull triple trailers. And each of those trucks has a gross vehicle weight of 156,000 pounds. Each axle on the truck-trailer combination is loaded up to 20 kips, which is the legal limit for interstate-type traffic, 20,000 pounds. So we're using the actual maximum axle load that is allowed on interstate highways. So we're not overloading test sections. We're just applying the maximum amount of load and using 5 trucks running around the track for 16 hours a day, 6 days a week to really accumulate a lot of traffic in a short amount of time. Our goal is to have 10 million 18,000 pound equivalent single axle loads on the track in each cycle. And so that 10 million easels is about what you might see on a heavy interstate that would be probably between 5 and 10 years of traffic. So we're compressing that lifetime of traffic into a 2-year period. All right, so that was kind of a quick explanation of the build and the cost. Is there any more information you want there? Because there were some other things that you asked, Brett, that I didn't kind of get into in that answer.
Yeah, I think you really gave some good detail of why that price tag starts to get kind of expensive. And so the other part of the question I was hoping to get a little bit is just some of those stories on implementation successes where the client really has that ROI from putting the money into this experiment, but then the things that they learned from it really have helped their agency or helped their companies really move these things forward and really been a win for the industry and for the agency.
Yeah, there have been a number of experiments that I think were very helpful for the industry. You go back to the very first cycle. The primary research objective in that first cycle was to evaluate SuperPave and how SuperPave mixes would stand up under that very heavy loading. And so we had quite a few states put down their SuperPave mixes, their new SuperPave mixes. Some of them also evaluated their current mixes, their Marshall mixes, if you will, but most of them wanted to put down SuperPave. And we proved without a doubt that SuperPave mixes were very rut resistant using aggregates from, half a dozen different states. We used gradations that were coarse graded and fine graded. And many of those test sections were left in place for more than that first cycle. And we gained a lot of experience, not just about rutting resistance, but also the durability. And we learned that we could produce fine graded mixes. Fine graded SuperPave mixes would perform just as well as the coarse graded mixes. That was a little bit contrary to, I think, the expectation when we built that experiment. I think the trend of thinking in early SuperPave days is we had to make mixes coarse to be rut resistant. And we certainly proved in that first round of test sections that was not necessary. We could use finer graded mixes. One of the other experiments in that first cycle was SMA. SMA had kind of hit the U.S. about 5 years earlier in the mid-90s. And it was very successful in the states that had used SMA up to that point in time. And the SMA mixes obviously held up very well on the test track and gave some states more confidence that they could use SMA. I'll think of the state of Mississippi, for example. One of the things that we were taught about SMA mixes is that we had to use crushed hard aggregate. And the state of Mississippi is a state that it really doesn't have a lot of crushed stone sources. They do have a few, and then they import some crushed stone from other states, but most of Mississippi uses gravel for asphalt mixes. And by putting down some gravel SMA mixes on the test track, And it gave Mississippi DOT confidence that they could use their natural aggregates in that state, save them a lot of money. Instead of having to import all the aggregate for an SMA, they could use their natural aggregates that they were using in dense graded mixes. That's a really good example of kind of experiment that paid off very quickly. Another great example is the experiment that the Alabama Department of Transportation wanted us to do to re-examine the asphalt layer coefficient. If you remember the original AASHTO layer coefficients in the pavement design procedure that many of the states still use, but certainly was in vogue for virtually all the states 20 years ago, was based on the AASHTO road experiment in Illinois. They came up with a recommended coefficient for asphalt mixes of 0.44. We knew that there'd been a lot of technological improvements in asphalt mixes since the 50s when the AASHTO road experiment was built. Better quality aggregates, now the super pave binders, polymer modification, even quality assurance has significantly evolved. So the quality of construction is also, I think, an important factor about that influences that layer coefficient number. And so we needed to evaluate that layer coefficient variable for today's mixes. And we went through an experiment or evaluation of test sections that had been built on the test track. This was research that was led by Dr. David Tim here at Auburn University, and he recommended that the layer coefficient for Alabama be increased to 0.54. That's like an 18% increase in that layer coefficient. Well, that change in that layer coefficient essentially reduces the asphalt structure by 18% for a given traffic load. So by reducing the pavement cross-section, it's a more economical pavement design. What it essentially tells us is that we were over-designing pavement structures in many cases using the old AASHTO equations and the AASHTO layer coefficients. By reevaluating that layer coefficient through a series of evaluations, not only on the test track, but some other states have done some similar things, it's just really been, I think, one of the most significant cost-benefit ratios of all experiments that we've done on the test track.
So I'm going to take a little bit different direction on this question because the test track is known for its asphalt research, but the reality is the facility that it's located in has other research that's being done there related to either driverless vehicles or stormwater. It even hosted a mini Baja competition about 15 years or so ago. What are some of the other things that facility is being used for so that people listening might say, well, hey, I need more than just asphalt research. Here may be some other opportunities for me to work with Auburn as well.
Yeah, the test track sits on 300 acres of land, and there are a number of other civil engineering applications and test sites there on that 300 acres. There's a couple of geotechnical sites that they test deep foundations. There's an erosion and sediment control facility that's adjacent to the test track and right off one of the curves of the track. So they're evaluating things that we can do to minimize erosion of slopes and minimize the issues of when we do disturb the ground, how do we minimize not just erosion, but that sediment getting into our ground, our surface waters and streams and things like that. Richard, you also touched on the use of the track for vehicle research. So at Auburn University, there's some faculty in mechanical engineering, and they've used the test track to do some testing on truck platooning, where we bring trucks together to improve their aerodynamic efficiency. They're exploring other technologies to do driverless trucks. That technology is quickly evolving. We're really excited about that potential in the future of actually having our own fleet being driverless trucks, but we're not there yet. We'll have to figure out a lot of things about how do we fuel those trucks and things like that. But there is a lot of great research, not just at Auburn University, but around the world around autonomous vehicles. One little side note is I bought a Tesla a Model 3 about 4.5 years ago, and I can drive around the track and completely take my hands off the wheel, and it'll just keep going. It'll keep going whatever speed I set it. So the technology's almost there. There's research being done on the trucks themselves. The aerodynamic effects of certain things that they can add to trucks and trailers have been evaluated on the track. There's also tire testing that we've done on the trucks and the trailers at the track, and many different opportunities just to evaluate asphalt pavement test sections.
Yeah, that's really interesting. So to change gears just a little bit, I'm kind of curious. We talked about some of the impacts of the research and the return on those investments, but I'm also kind of curious, like if you could maybe share a little bit about some of the people that have graduated from the program or been part of the program and have moved on, and some of the places that they're working in the industry or in different areas, and just learn a little bit about that impact of this research and the program at NCAT as well.
Yeah, that is one of the real significant side benefits of the research program at NCAT is that we have young engineers, young graduates, and even co-op students that have worked in the lab and on the track that have gone on to continue their careers in different areas of the industry. We've got folks that are working for the DOTs in various levels of DOTs, working for the contracting industry, working for associations. Richard Willis is a great example of someone that has started at NCAT doing research and moved to Napa, and has really, I think, a good example for other people to have that kind of aspiration. We've got several other folks that have done similar thing and gone to work for state asphalt pavement associations. And then consultants, material suppliers. So the asphalt research program, the graduate program, has been one of those, I guess, side benefits of what we do at NCAT. But it's really, I think, when you look back after 10 years, 20 years, and you see people that have gone on and been very successful, that just kind of makes us all at NCAT very proud. It's good to have those connections and to see them prosper and do well and continue on the idea of taking that research and expanding it even further in academic positions. That's been another area where we've had researchers going on to other universities and continue to teach and to do research.
Randy, we really appreciate you spending some time with us today and talking to us a little bit about the test track and what NCAT is doing for the industry. And we just continue to wish you success, especially as you're starting to get ready for the build next year. And if you have any questions about being a part of the track and you're listening, don't hesitate to reach out to Randy or Buzz and see what your state could potentially learn and benefit from on the track.
It's going to be an exciting summer. This is the summer before the next cycle where we build new test sections. So we're going to be out talking to sponsors and seeing what kind of research they have in mind for the future. So thanks so much, Brett, Richard. It's always great to talk to you guys.
Thanks, Randy.
You. So I think my takeaway from today really, I don't know how to say it, but like I'm familiar with NCAT, but it always, I think, hits me like how much research, how much effort is put into understanding our pavements, to getting our pavements to last longer, perform better, do what we're asking them to do out there, carrying traffic and moving people around to the places they need to be. And I don't think people understand that always. And so, but it really strikes me just that the amount of effort that's put into advancing asphalt pavements.
You know, when I think about the test track and I think about its research, one of the words that comes to my mind first and foremost is value. Like there are some things that are expensive, but if there's value behind it, it's worth it. And when you look at the research that the test track does, it is boots on the ground or asphalt on the road, whatever you want to call it, practical, implementable research that can make a difference. It's something that when you get to the end of it, you're not going to be wondering, is it going to last on my road? You're going to know if it's going to last when you place it. The other thing in terms of value that Randy didn't even touch on, but I know from inside baseball knowledge of being there, is while you're paying for your experiment, you're also garnering the knowledge from every other experiment that's taking place there through the sponsor meetings and the test track conference and those other avenues for technology transfer. So yeah, while the price tag is not cheap, it's not just your experiment that you're getting the value from. You're getting to have those conversations on all of the other state DOT or industry problems that they're trying to find solutions for. So don't doubt the value that's in your dollar when you're sponsoring there.
Thanks for listening to Pave It Black. Visit asphaltpavement.org/podcast to find more episodes, suggest a topic or guest, become a sponsor, or learn more about Napa. Pave It Black is produced and copyrighted by the National Asphalt Pavement Association. Music by Colleague. As always, thanks to the dedicated workforce connecting diverse communities all across America. Keep on paving it black.